Hello, in this video tutorial, I'm going to look at avro tools and how to create a hive table over avro data that you wrote to HDFS in the previous tutorials. If you open a terminal window by clicking at the top from the Cloudera within the VMware where you got installed the Cloudera, and from the terminal windows, if I type in avro-tools, it'll give you different options that you can use. You can do a cat, you can get the schema, you can convert it to JSON, you can look at the JSON, and then you can convert it to true Trevini format, which is a columnar file format, and so on. So in here, we'll just focus on a few of these commands. So firstly, here I'm going to do avro tools. I'm going to use the one called toJSON. So to here is a toJSON. So it says dumps an avro data file as JSON, record per line or pretty print. And then I'm providing a path to the HDFS, which is a quick start at cloudera.8020, which is a name node URL. User cloudera avro orders and part R00 avro. It's the actual avro file itself within the orders, and it is going to output as a JSON file. So if you know this path, we already looked at it here. So that's the user cloudera avro orders, which is from the file, and you can see the file browser, which is HDFS file browser. This part R00.avro, that's the file we are outputting. So you can see the three entries here: 1 2 3 4 5 6 7 8 9, John, Peter and Samuel. One is the order ID, another one is order name. So the one that I'm now interested in is schema. So you need a schema to be able to create a hive table. So here, to do that, I've got to do avro tools, and I can do get schema. So that's the method here, which is get schema, prints out the schema of an avro data file. So if I say enter, it's going to output that to the screen here. Now if I want to create, that's the schema. So you got the type record, name, order type, namespace is com.mytutorial. Then the fields you have order ID, which is of type integer, order name, which is nullable, is of type string. So the next step is I want to output, so I pipe that to order.avsc file. So this will be outputting the records. Okay, there might be already an order.avsc file here. Which folder am I in? Okay, so I changed directory to my home directory, so cd home, up arrow again, and then order.avsc. So this will be outputting. So if I do now lsltr, I can see a file here called order.avsc. Now if I do a cat, I type order.avsc, so you get the same output. So now what I'm going to do is this order.avsc, I'm going to upload that to the HDFS. So here you can see I have already done that, but I'm going to demonstrate that again. And order.avsc, you look at the date, which was on the 29th. Today is 30th. So if I'm going to do it again, in Cloudera there is in Hadoop FS system there is a command where you put a -f that will override any file that is already there. So I'm going to paste this command here. So Hadoop FS -put -f is to override any file that is already there, and order.avsc is sitting in the Linux system, that's in here, and I'm going to upload that to HDFS quick start Cloudera 8020, which is a name service, user Cloudera avro order.avsc. So this should overwrite the file that is already there. So once this file is uploaded to HDFS, so if I go to the file browser again and I just refresh this, so that file should have been uploaded. It is a bit slower because in the Cloudera Manager I'm running all the services. So you can see it says till 29th. So order.avsc is the file, and if I drill into it, I can see the schema here. So now why we need the schema here? So we need the schema and the actual location where the files are sitting, so that will be under orders here. So now I go into Hue editor. I should be able to create a table called avro order. I've already created this, so what I'll do is I'll first drop this table. So all you have to do is drop table. So this table is created in the so we are in the learn Hadoop database, so it will be created inside the learn Hadoop database itself. So drop table avro order. So this is the power of Hive now. So you use your family SQL statements. These are not 100% ANSI compliant, but they are called the Hadoop query language, which is very similar to SQL. So the data analyst or data scientist can come and execute this. So I have dropped this, so you can see that table avro underscore order has disappeared. So avro is not a meaningful name. You don't call it avro, you call it some meaningful name. This is in this case purposely I'm prefixing it with avro just to show that we are creating a Hive table on top of avro. So in one of the previous tutorial we looked at, we can create a Hive table on top of a CSV file. So when you run select queries, it runs a MapReduce or a Spark job, and then it goes and retrieve the data. So very similar to that here. So I've dropped it. So now I'm going to create a table. So it's called the create external table. It's called the external table because if you drop the table, still this file will be there. It's not going to delete the orders folder. But if you create a manage table, when you drop a table, the data underneath will be deleted as well. So in this case, an external table, and only if not exist, we are creating something called avro order. And then you always have to provide the search. So serialization stands for serialization deserialization. It is going to use the avro serialization deserialization class. Stored as input format, which is the avro container input format. And the output format is avro container output format. So avro container input and avro container output. And the location is actually the location of where your physical file, the avro files, are sitting. So that will be under user Cloudera avro orders. You only go up to the folder. You don't go specify the actual part xxx.avro file name, but the folder. So in this case, the folder is just orders, under which we have the part files. So we got the part 00 avro and so on. And then this is the next part. So you can have an inline schema. So for example, I can say avro schema URL. I think there's a syntax to say this inline, and then you can actually type in the schema itself. So the way it looks here, so you got to type the whole text. You got to type the whole text, or alternatively, you say the URL and provide the path to where the schema is sitting. So that's why we created the schema, extract out the schema from the file. We called it order.avsc and then uploaded it to HDFS, and then from the Hive, the Hue screen here, we are specifying. So you can also run this on the Hive shell as well. More detail is in the Hive tutorial, so how to run it on Hive shell and so on. So here the avro schema URL will provide the path to that, and then if I run this, it should create a table. Looking at the schema, it will figure out how many columns to be created, and then also to look at the data and then organize the data as well. So if I go and highlight this and press the play button, now it has created the table, and you should see that table on in this side. So my text, so here is go avro underscore order. So that's the table that we have created. So avro underscore order is just a table. It tells you where the schema is and where the actual file is. And when I do the select star, by default, whether it's a MapReduce engine or a Spark engine, or depending on, so you can change the engine. So it runs a MapReduce job or a Spark job or a test job, and then it goes and retrieve the data what you need from this underlying file or underlying folder. So if I do now select star, it will be kicking off a MapReduce job, and it has gone and brought in 1, 2, 3 John, 4, 5, 6 Peter, 7, 8, 9 Samuel. So if I want to put something else like a where clause, if I want to say where order underscore id equals 1, 2, 3, and I select this and press the play button, and it should only bring in the John order id 1, 2, 3. So to the underlying any file format, whether it's Parquet, Avro, CSV, you can always create a hive table, but some of the things you type in here will be different. So you can always Google for say hive table Parquet or hive table Avro or hive table CSV. You will actually get this syntax. So if you are doing a CSV, then you have to specify the column names, what column names you need, and also then you got to put a delimiter, so if it is a comma or pipe or whatever. So there are syntaxes are slightly different depending on what is the underlying file type is, and then any other query run, whether you select or you can say insert, all those queries are very similar to SQL. So this is still running, and while it's still running, I can also now go into here and in the jobs I can see what job it is running. So basically it will be either MapReduce or a Spark, whichever is default, but you can always change the execution engine from MapReduce to Spark or from Spark to MapReduce. So it's coming up. So if I click on the running, so it will show you all the jobs. So if you want to filter it by only the running ones, you can see it here. Here we go. So it says select star from avro order where order id is equal to 1, 2, 3. So it's running as a MapReduce job. It's still in the, we saw in the Spark it goes from accepted to running, and from running to completed or failed status. So it's still in the accepted status. Actually I should have opened this in a new window. It's okay. So now I'm going to select this, and I'm going to go back into Hive by selecting tables. I'm right click on it and open link in a new tab. So I got another tab, so I can switch between. So I got the file browser here, I got the job browser here to see what job it is running under the covers. Then I'm going into the Hive table so that I can run my select queries. So generally running Spark jobs can be resource intensive, and this is only running with 10 GB of memory. So sometimes I go into the CloudRack manager, and before running these jobs I can stop the HBase because HBase is not required, and I can stop few other jobs like Uzi, workflow, and I can't stop the Zookeeper because Zookeeper is required for Hive. Then I can stop some other jobs to give it more resource to the area that I'm working in. But in this case I'm just going to wait for the job to, so it's still okay. Here we go. So it's succeeded now. So that means I know this job is finished. Now if I go to my table browser, I could run it again because I would have lost it. So Hive, There's an Impala. So Impala is very similar. You can use SQL, but it is more efficient than the Hive. It heavily uses memory to retrieve data. So this is the last Spark job, the thing I ran. So because I moved to another one, I have lost it. So I'm going to select this and run it again. Here we go. So that's what it is. 1 2 3 John, because we have only asked for order ID 1 2 3. It's given us John. So quickly to recap, so we have already, when we started the tutorial, we already had avro file stored. So what we did when we used the avro tools to extract out the avro schema, wrote it to a file called order.avro schema. avsc file stands for avro schema, and we uploaded that onto hdfs. Then we came into hue and to the hive, and then we created an external table. So we had to provide the avro schema URL path and also the location of the actual data, the folder where the data is residing. And once we created a table, then we were able to execute SQL queries. So in the next set of tutorials, we'll do very similar stuff. In this case, we looked at avro. We'll be looking at something called Parquet. So Parquet is a columnar format. We'll be storing data slightly differently. So here I'll be storing like 1 2 3 John 4 5 6, whatever the name, but in a Parquet file, it will be keeping all the order IDs sequentially. So it will be 1 2 3 4 5 1 2 3 comma 4 5 6 comma 7 8 9. All the columns will be stored together, and then the next column John, Samuel, and so on will be stored together. So the benefit of that is, this is a very trivial example, only had 2 columns, but a typical avro or a Parquet file might have hundreds of columns. So when you're doing a select query and so on, mostly you won't be selecting all the 100 columns. You will be handpicking about 5. So if you want to compute some stats or something, you might be handpicking some salary column and a couple of other columns. So in that scenario, avro is not very efficient. So avro is only efficient if you are trying to select all the columns from a record, because it's storing everything record by record. So if you are storing something 100 columns or something, and at a time when you're doing a select query via Hive, you'll be only selecting 5 columns or 10 columns or a handful, maybe even 20 columns, then Parquet is more efficient, because it'll go to those 20 columns and retrieving it pretty quickly, and it won't be looking at the other columns at all. Where if you're doing an avro, it's going to scan each row at a time and just pick those 5 columns, which is a lot less efficient. So avro is slightly more efficient when you write it via Spark job, but when you're reading it via Hive or reading it via Spark SQL or whatever, it's not as efficient as Parquet. So Parquet might take a little bit longer to write, but when you're reading it via Hive or Spark SQL or something, it's a lot more efficient, because when you're selecting a subset of all the columns that you have.